The software we'll be using is called R. There used to be a software called S for statistics from IBM. It was quite expensive, and then some people thought, oh, we do some sort of open source version of that software, and they came up with R. I think we talk about HTML in the early weeks and SGML? No, okay, because that's some sort of repeating pattern, IBM invented lots of things, and for one reason or another, they didn't always keep on top of things, and sometimes, even though they invented something, they lost dominance in that field, and this is kind of what's going on here. I think the main problem was that S is so expensive, or I think it's called S Plus now. So R is one of the most popular programming languages these days. It's quite hot, and especially with big data appearing and being more and more important, R is quite useful to deal with huge amounts of data. Down the line in the final year, or down the line, you might have an option to pick other modules, and one of them might work with Tableau. Have you heard of Tableau, or any lecturer mentioned it to you? No. Tableau is quite good, and it makes it easy to produce nice charts, but Tableau costs a lot of money. R, the one we'll be using, is completely free. It's used a lot in industry where statistics are important. It's used a lot in academia. Okay. You can work from a UCLAN machine. You can work from your own laptop. If you work from a UCLAN machine, you start the application catalog. I'm just starting it now. So here's the application catalog. But somehow I think one letter is too short for the search bar here at the top to pick it up. So if you want to install it from a UCLAN machine, on a UCLAN machine, search for CRAN. And here you've got different versions of R. Here's 3.4 is the later version. So you can install R here. We'll install R first. That's the statistics software, and later we'll install RStudio. RStudio is some sort of integrated development environment. Basically, if you write R code, if you create statistics using R, it makes it much easier to find mistakes you've made, because we'll have variables, we can see what's in those variables. So it's much easier to basically look under the bonnet and to see what's going on. But first we need to install R. And the alternative is, if you work on your private machine, you go to R project and you download R. It's available for Windows. It's available for Apple, Macs, for Unix, and so on. A mirror, there are basically different web pages around the world that host the files. UK, so let's pick something here, and here are different links. This is a Windows tablet I'm using, so I want to download R for Windows. This is what you want to install R for the first time. Okay. I never installed it on this machine, so I want to install it now. So I download it. It's downloading here. So my suggestion is download it on your own machine as well. Then you can work from home and from UCLAN. Or if you bring your own machine to the workshops, that's also good. Then you only have one machine to work on. Okay, nearly there. 75 megabytes to download. Yeah, here we are. Open. So on my other screen it says, do you want to allow this application to change your device? Yeah. I'll keep pulling the windows onto your screen. Okay, welcome. Next. Yeah. If you have too much time on your hands, have a read. The folder where you want to install it. This is the setup for your own laptop. If you install it with the application catalog on a Uclan machine, it wouldn't ask you all those things. It would install it automatically. Yeah, next. Do you want to customize the startup options? No, let's just leave that. Shortcut. This is all fine. So if you got your own laptop, install it at the same time maybe, and then if you've got any issues, you can let me know and we can look at it together. Okay, finish. And here it is. Most machines these days are 64-bit machines, so I'll try that. Okay, here we are. And that looks quite old-fashioned, I guess. This is the R console. It's a bit like a, MS-DOS prompt or a, console on a Unix machine. We can type commands here. And at the moment, we can just type one command after another. Now down the line, if we want to produce proper statistics, we can put all our commands in a file, basically a text file. And let's say we got 10 commands, we want to run one after the other, and running those 10 commands one after the other will produce the statistics we want to see. Instead of remembering them, typing them in every time, we can save those commands in the correct order in a file, and if we want to run those statistics, we basically just run that file. The idea is that we'll make our results reproducible. It's all nice and good if you want to do some calculations, and at the moment it's probably a bit small, but let's see, can I zoom in? Yeah, so I could just type commands. Let's say 1 + 1, and now I get the answer 1 + 1 is 2. Or 5, yeah, 5 times 7, 35. Okay, so I could just type commands here one by one, and those commands will come up with some sort of output. But the idea is we save all those commands in a file, and we can then run those commands. Okay, let's start with simple stuff. We've got addition, we've got multiplication, we've got subtraction, division. Have a guess? How does division look like? Yeah, okay, here we are. Exponentiation. Yeah, I don't know, 4, or let's say 2 to the power of 8. And we got modulo. That's quite useful in programming. So depending on what modules you do in the second year, you might come across it or not. Modulo basically is the remainder of a division. So let's say 27 divided by 3, and then we want to see what's the remainder of the division. Is that right? Yeah. So 27 divided by 3. How often does that fit? That fits 9 times. So there's no remainder. 27 divided by 4. How often does that fit? I'm lazy, so I'm just gonna figure it out here. It fits 6 times, and then the remainder of the division is 3. In computer science, you often need that. You'd think now, oh, this is such an odd kind of calculation. Why do we ever need it? But it's just amazing how often this will come in useful. Okay. So far, this is all stuff you've seen before, maybe except the modular. I mean, exponentiation you should have also done before. So my next question is, who has done programming for their A-levels or in their past? Computer programming. Which language did you do?
PHP.
You did PHP?
Yeah.
Oh, there's a second year module you'd like, which is called BT2201.
But I could understand and reading them, but not writing them.
Okay, there's a whole module about PHP, so that might be interesting. Which language did you do? Okay. So something that all programming languages have in common are variables. I should, let me type that out. Variables. Okay, why did I type a hashtag first? If I type a hashtag, I'll make something a comment. That means I can write little comments for myself in my code to remind me of things down the line. If I would just type variables, now I get a other message. What does that mean? But if you want to write comments in your code, put a hashtag first. It means what you do next is a comment. So what are variables? Variables are our short-term memory. We want to remember some number in this case to deal with later. We basically put it into a variable. We can store values. We can store more complex things called objects. We talk about those another time. Example is, I don't know, let's say you want to calculate, you can write a little program that will calculate the VAT of a product. How much is the VAT? 20%, yeah. And we can write a little program, but actually the calculation we do is always the same. So which way around do we want to do it? Do we have a price without VAT and we want to add VAT, or do we have the final price and we want to figure out how much VAT is? So the more difficult way. Yeah, okay. So let's say something costs $9.99. Okay, how do we calculate the VAT? The VAT was 20% off the original price, or
divide by 1.2.
Should we divide by 1.2? Okay, so let's say something is £10. If we divide by 1.2, that means originally it was £8.33, roughly £8.33, and then they added 20%. Times 1.2, and then we are nearly at 10 quid. So we might want to do this kind of calculation quite often. We can write a little program. We take some sort of input. We put that input in a variable, and we do stuff with that input. For example, we divide it by 1.2. There might be more complex things we want to do. I mean, this is a very simple example. It's not really worth the effort. But the more complex things we do, the more steps we want to do with some sort of number the more it makes sense to put it into a variable. We then end up with a program that will work independent of the input we feed in. Yeah? We create some sort of program. We feed this program some input, we get some output in the end. There might be one or several numbers we need to remember along the way. We put them into a variable. Now, in R, a variable can, you just start naming a variable. I'm saying that because in some programming languages, variables have a certain look to them. So, for example, in PHP, because you mentioned PHP before, in PHP, variables always start with the $sign. In R, this is not the case. So, if you want to name something, if you want to put some value somewhere, we can call it whatever we want to call it. For example, price. Yeah. So the variable will be some sort of container. We can put something in. So let's say I want to put a price into this variable named price. I could do it like this. Price is $9.99. And we'll remember that now. If I want to see what price is, I just type price and I get the answer. I can have as many of those variables as I want. Yeah. VAT is different in different countries. Yeah. So in the UK it's 20%. So I could store it. Should I write 20? Oops. Should I write 20 or should I write 0.2? It depends on how you do the rest of the calculation. Yeah. Now I remember price and VAT. Yeah, price, VAT. I can do calculations with variables. Price times VAT. And I get the answer. So I can store numbers in variables. I can do calculation with variables. If you're used to other programming languages, you probably use the equal sign. Yeah. I could use the equal sign here. And yeah. This first shows me that I can use the equal sign to assign a value to a variable. And it also shows me what happens if I put a value into a variable but there was already a value in the variable before. You see, before, price was $9.99. If I put another value in, it will just get overwritten. The system will not give me a warning message. Oh, careful, there's already something in there. It will not do anything like that. If I tell the computer the price is gonna be $8.99, the computer will just follow my orders. It doesn't care whether there was something else in before. So you got to be careful because you don't always get a warning message. We also see that we can use the equal sign, but I advise you against using the equal sign. I prefer the equal sign because on the British keyboard the equal sign is just pressing one key. On the British keyboard, doing this, I have to press 3 keys. 3 times as many keys to make this happen. Yeah. Shift and comma for this symbol and then hyphen. The reason why you shouldn't use the equal sign is it doesn't work in all instances. It's quite complicated, but it will work here on the main level, let's call it that. But the equal sign will not work on all layers of R. It will only work on some layers of R. So the easy way out is you just forget about the equal sign and you remember if you want to assign a value to a variable, just create this little arrow. You think this will work? Will this work? Let's find out. It worked. But yeah, usually everybody does it this way around. Okay. In R, we've got data structures, and the most simple data structure is a vector. Have you heard of vectors before? You might have done it when you did maths in school. Did you do vectors?
Yeah.
You remember the name, yeah. I think there are different ideas what vectors are, and then you can often draw them. If the vector has two numbers, you could draw it on a two-dimensional sheet of paper easily. But it's basically some sort of ordered collection of numbers. I can put numbers into a vector. In computing, you could also call it an array or a one-dimensional array. But basically, we could put in lots of numbers. And the system will remember those numbers in the same order. So a variable can not only hold a single value, it could also hold a vector, for example. And a vector itself consists of many numbers. So if you've done computer programming, think of a one-dimensional array. Okay. I'll create a variable called food cost. I want to record all the money I spent on food this week. And today I'm gonna go to the Students' Union. They have this lunch deal, sandwich and crisps and a drink for $3.29. Yeah. So in this case, I could store the food cost for today. And we've got one number in there. But I can also store many numbers here. Yeah, okay. Food cost. Okay, how do we store more than one number? I use a command C. C stands for combine. Yeah. So I can now put lots of numbers in there. Yeah. I open brackets, I close them, and now I can put lots of numbers in there. So Monday, what did we eat? How much did you spend on your lunch on Monday? Let's say it's the meal deal from the Students' Union, $3.29. And on Tuesday, £5. And Wednesday, £10. Oh, a nice meal on Wednesday. Thursday, I look and sometimes I have spaces, sometimes I don't have spaces. It's usually fine. It would be nice if you were consistent, but the system is slightly forgiving with those kind of things. So Monday, Tuesday, Wednesday. Let's do Thursday. How much did we spend on our food on Thursday, on our lunch? $1.99. Where do you get a $1.99 deal? McDonald's? Oh yeah, they do. Or do you get? Oh, is it the wrap of the day? So Monday, Tuesday, Wednesday, Thursday. What did we eat on Friday? How much did we spend?
Yeah.
Is it your fasting day? Okay. And Saturday? 20 quid. Monday, so we got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. How much did we spend? $12.50. Okay. So let's try that out. That should be stored in food cost now. Food cost. Yeah. And this is a vector, yeah? So we've got all those numbers we entered before, they're all stored here. Okay, let's say we travel by bus to the university. Let's store how much, our travel, let's say travel costs. Yeah. Maybe sometimes we take the bus, sometimes we take the taxi. Cost. And I closed the brackets already so that I don't forget to do it later. I could just close the brackets in the end, but I'll close them now, then I don't forget doing it later. So Monday, how much did it cost us? Did we walk? Did we use the bus? $3.50, thank you. And I could even write 3.5, that would work. Tuesday? Walked, good, healthy. Wednesday? Oh, comfy. We also ate a lot on Wednesday. Look, on Wednesday we also ate for 10 quid. Thursday? We walked again, good. Friday? Yeah, we wouldn't want to walk on the day we don't eat anything. Saturday? No, we didn't come. Okay, Sunday we also didn't come. Okay, send it off. Oops. What's wrong here? I got the C missing. Thank you for spotting it. And if you want to repeat the last line, good, this happened. If you, and I want to type it all in again. If you press arrow up, you get the last line again. If you press arrow up again, you get the second last line, and so on. This is very common. Also, if you work on a console, on a Unix or Mac system. I'm not sure in MS-DOS whether it works the same way, but on any sort of Unix system, pressing arrow up will give you the last sort of input. And well spotted, we forgot the C. C for combine. Okay, so we have travel costs. Let's see whether it's really in there. Yeah. Okay. So to make my life, my label, reading the data a bit more comfy, I can actually also introduce labels. Yeah. So I want to label all the days of the week that we are using. Let's call it days. Yeah, and now we got Monday. And now I got to put it in double quotes because it's not a number, it's a string. And because it is a string, there could be a space in the middle. Yeah? I mean, there is no space in the middle, but there could be. And then that would really throw the whole system off. It wouldn't know after the space, is this still part of the same string or is this something else? So whenever we deal with strings, with characters, with letters, we usually have to put it in double quotes. Tuesday, Wednesday, Thursday, Friday, Saturday, wait, Sunday. Okay, here we are. Hope I didn't make any mistake. Yay. Okay, that works. So far those two things are separate, but I can now tell the whole system that the days are is basically the label for my food cost vector. Yeah. So they're gonna be the names. So the command here is names food cost. Or let's run food cost by itself again. Food cost. Yeah. Yeah, I only get the numbers. And days, I get the days. So now I'm gonna do names, food cost, yeah. And what some other trick? Again, it's the same as in a Unix Linux system or in an Apple Mac system. If you want to automatically complete the name of something, let's say the name of a file or whatever, you press the tab key. I can also just press tab here, because there's only one variable that starts with food. I press tab, it will automatically complete the name food underscore cost. If I had food underscore cost and food underscore calories, yeah, then it wouldn't know what to do. If I press tab, it doesn't know, does he want cost or calories or what. But because there's only one way of ending this variable, pressing the tab key completed the name. Days. So I'm now saying the names for the food cost. Yeah, for the names, you can actually use those days here, that vector I created earlier. Okay, let's have a look at food cost again. And now when I look at food costs, I get my data labeled nicely. What did I spend on food? Should we have a look? Sum. We'll sum it all up. Food cost. Yeah, so we spent £52.78 on food. Tell me, how do I calculate how much we spent on traveling? Yay, £17 we spent on travel. Okay. Yeah, those names. Yeah, I thought it was a good idea to make the days the names for my food cost. So I want to do the same thing now for travel cost. So what do I do? Because at the moment, travel cost, where are we? Travel cost here. We don't have labels yet. So I want to put those labels that I stored in days. I want to apply those labels also to travel cost. Say it again. Names, and then yeah. Yeah. Okay. Let's try it again. Travel costs. Yay. Okay. Now, the system knows that travel cost is a vector with 7 numbers in it. And the system knows that food cost is a vector with 7 numbers in it. So now comes the cool bit about R, or at least if you're geeky, you'll find it cool. Let's think back of earlier. We can just add up 2 numbers. 7 plus 2. Yeah, it will add up those numbers. But what do you think will happen if I add 2 vectors? So let's say I want to add up food cost and bus cost. Will it come up with basically 52.78 plus 17? That's one possible explanation. So we'll get something like 69.78. Or what do I get if I add up food cost and travel cost? 14? Yeah, good thinking. It could just add up the numbers of elements stored in the vector. Yeah, you see there are lots of possibilities, but that's the really cool thing here. If we add up daily costs is food cost plus travel cost. If we do that, let's have a look at what daily. So I want to look what daily cost contains now. How do I do that? So what did it do? It added. Yeah, let's show food cost again and travel cost. Yeah, so it added up the cost on Monday for food and the cost on Monday for travel. Yeah, it ended up how much we spent on Tuesday for food and for travel. It added up what we spent on Wednesday. So if I add two vectors, it will basically take the first element of the first vector and add up the first element of the second vector. Yeah? Okay. If I stand here, it's probably easier. Yeah. So the first element of the first vector I added up with the first element of the second vector, and it becomes the first element of our new vector. And it doesn't have to be addition, it could be any kind of operation. If I could do subtraction, exponentiation, whatever I might do, I will do the same thing. So in R we often work with vectors, and the vectors, they often have long sequences of numbers. They could be readings from a machine. Yeah, the machine measures, I don't know, you're filling packets of sugar, and it measures how heavy the packet is every time. Maybe it's supposed to be 500 grams. Sometimes it's 502. Sometimes it's 498. We could have a vector with thousands of numbers of sugar packet measurements from our factory, and we then basically look at all those elements and we can produce statistics, we can produce graphs. So very often in R we work with vectors, and if we add vectors up or do any other kind of operation, we actually do this kind of operation with the different elements of the different vectors. This is why R is very popular, very useful for statistics, because in statistics, very often, statistics is not about two numbers, like here in this example, 7 plus 2. There's not much statistics you can do with two numbers. When you do statistics, usually you've got lots of numbers. And in R you can store those lots of numbers in a vector. Okay, this is quite good. And the whole thing gets even better if we start using RStudio. So if I want to install RStudio, at UCLan you use the application catalog again. Yeah, because I zoomed in now, it looks a bit funny. So RStudio. I'd have to zoom out again, but I think it's not worth the effort. Yeah, so here's RStudio. You want to install it, you click on install. Or if you do it on your own machine, Studio. Sure. I downloaded the open source edition, the free version. Yeah, I want the free version. Okay, I got this tablet is Windows, so I download the Windows version. But if you got a Mac or Unix, Linux, there are versions here as well. RStudio. I'm not sure, it might complain now because R is already open, but we'll see. Okay, here we are. So the nice thing here with RStudio is it makes it much easier to work with files. Now, so far we typed everything in by ourselves, but in reality I want this kind of stuff that I'm doing to be reproducible. I want to be able to run it many times. I want to be able to make sure I always come up with the same output. So the sequence of commands, I want to store it. And if I do anything, I might also want to see what's going on. So here was our food cost. I'm just lazy. I'll copy and paste it now. Okay. So I put food cost here into a variable, and the nice thing here is, look, I can see all the variables that our system currently holds in its memory. So I can see now there's a variable called food cost, and it's numeric, meaning there are numbers inside. So there's food costs. What was the next thing? Was the days or travel cost? So paste that here. Here it's also numeric, and we can see there's 7 elements. Days. So RStudio makes it easier to work, because I can see immediately what variables are already in the memory. What can I work with? And here I can see there are characters. I can see how long the whole thing is. It's 464 bytes. That's not really of concern for us, but for some people that might be important. And here, if I look here, if I hover over with the mouse, I can see what's what are the elements stored in there. What else did we do? And now food. Now I applied the names. Now food cost changed from numeric to named numeric here, because now it's named. The food cost. Travel costs. So normally we'd only work with RStudio. I just wanted to show you normal R first, so that you can actually see how RStudio is more comfortable to work with. Daily cost. Okay. Here you can also store your environment if you want to. You can ask the system to draw little diagrams, then they appear here. So overall, it's quite nice to work with. So in the future, we'll work with R files, and I can also use GitHub to give you an R file to work with. If I send you an R file using GitHub, it doesn't really make sense if you work on the web interface, because you can't really run the code in the web interface. If you work with R files, it makes more sense that you use GitHub Desktop. You then bring the files onto your hard disk. You can use those R files in RStudio, and if you make changes to those files in RStudio, you can just press the commit button in GitHub Desktop, and you can push your commits to the server. You can work with the uCloud machines, or if you want to bring your own laptop, and then you have the same kind of environment working at home and at uCloud. So yours is an Android, is it? Yeah. It's a shame. I mean, let's have a look. R for Android. Yeah. Yeah, might be worth having a look. There might be a. Yeah, no, because it's much heavier. Oh, you know, or you can always work on a uCloud machine. Okay, anyway, that's it for today. Thank you, and see you next week.